Yes. So.
Oh, so why are you recording already?
Yeah, because I want to show the demonstration.
Mfundo, please get away. No talking next to me.
Right, you have to format your USB. So there's the USB. Okay. Only one thing. Right, you have to format the USB. Right, format. Then you select FX32, F8032, default, start, okay, wait for it. We must have been unsafe for the lap. Unsafe for that. So it's done. Remove it. Then you come back to your oscilloscope. Alright. So we only have channel 1 and channel 2. Okay. Alright, so this is your signal generator. The first thing that you have to do, you have to measure your input waveform. You have to measure your input waveform. So you have to connect your signal generator to the oscilloscope. Okay, so right now it is connected. I just connected this wire, this cable from our TTL port, and then we connect it to channel 1 because the assignment said task number 1 we have to measure the waveform of the signal generator. Okay, and we measure the frequency of the signal generator, your clock frequency. Okay, my clock frequency is 13. So I'll just adjust this one. You see, then this is my square wave. So I have to make sure that this is giving me 13. So I'll go to measure, I click measure. Okay, and then there I want to measure my frequency but on channel 1. So I'll just change here, and then channel 1 is selected. If you want to measure channel 2, you change here so that it is channel 2. So it's channel 1, and then I want to measure my frequency. Frequency goes with time, so there is it, and then there is frequency. So there is my frequency. So I'll increase here until I get 13. So 13.0 up to 13.5. Not more than 13.5. So that is fine. 13.04. Right, that's my frequency. And there's my input frequency and input waveform. So insert the USB device installed successful, so which means the USB is working. And then now you have to save the waveform. You go to storage and then type of the storage that you want. It's supposed to be bitmap, not waveform, not wave, not setup. So you keep on changing here until you see bitmap, and then this destination is going to be our picture number 1. So if you want this picture to be picture number 2, you adjust this one. So the destination is going to be picture number 2. So this is our first picture, it's picture number 1, and then I'm going to save the waveform first. So I just, you press, you click on save. It is saving. So that is your picture number 1. So the picture number 2 is the frequency of this waveform. So I go to measure, I press F5, twice. Okay, there is the frequency, and now I want to save a picture, this picture, storage, and then I'm supposed to have bitmap there, and now it's destination number 2 because it's a second picture, and then I save that. Alright, so now is your circuit working? Is it working? Alright, so with power, to hide that, you press measure again and then F5, so that it goes back there. And then there is your positive, if your circuit is working.
I'm positive, now negative.
Okay, so negative this side.
Negative here, positive here.
I don't like that because you see you connected on the positive there. That is confusing. You were supposed to do it like this and then rotate the IC. Because now we are connecting black to red. I don't like that. Okay. So this is your clock. And then we connect pin 1. Is it pin 1? So it is working, right? And I would like to ground this. Okay. There is another. I need a connector here. Another probe. There. Or take that one there on top. So we need a picture. The first picture must be of the circuit. If you want to take a picture, you must take a picture of the circuit, the breadboard. And the second picture is the one of the waveform. The third picture is the frequency. Is it working? Alright, so we connect on channel 2.
A camera picture or the picture of the bitmap?
The bitmap is supposed to be picture 1, the waveform, but on your document, the first picture must be of your breadboard.
Okay.
Yeah, the one that you are going to use your phone to take that photo. Alright, so we measure on the output, not on the resistors there, not between the resistors and the LEDs, but on the pin of the IC. Okay?
Pin what?
Any on the output. I don't think this is working. Let us see. We are going to check it. You see? Oh, it is shaking. Okay. Yeah, it is working. So you have your clock and then your output. We know that the flip-flop is dividing the frequency into 2. So as you can see that one, I'll just zoom in. You see that the clock goes down and then goes up, and then this one will only change when the clock is going down. You see, the clock is going down, it changes. It goes down, it changes. It goes down, it changes. Okay, so we need to take a picture of that. So we go to storage and bitmap. This is going to be our third picture, and then we save the picture of the clock and the output. We are comparing the clock and the output, and we will have to measure the frequency of the output. So this frequency. So now we go to measure again, and then now we have to change that to channel 2. Okay, channel 2, frequency, there's our frequency. So we are not adjusting anything on the clock now. We know that our clock is 13 point something, so 13 divided by 2 is 6.5. So there it is. And then we have to show the full screen of that. So channel 2 parameters, and then there it is. Okay, and then you take a picture. So you go to storage, you change the bitmap. This is our picture number 4. Alright, and then you save. Alright, so now to hide this, you press measure and then you press F5 so that it goes back there. So now we must have 4 pictures inside here. Alright, so let us check. Let us remove our USB and then we go to the computer to check these pictures. Alright, inside the USB there is our USB with the DSO with our pictures inside. That's a picture, the first picture that we took. This is the second picture of the frequency of that clock. The third one is a picture showing your clock. We are comparing your clock to the output. This is the input, that is the output. So it the flip-flop divides the frequency by 2 because this is the input frequency, this is the output frequency, and then there it is. You see that we have 13 there and we have 6.5 here. So you just copy that, you open your Microsoft and then you just paste it there. Okay, so there must be a picture of your breadboard circuit connected in a breadboard and these pictures, and then you are done. Okay, and then you are done.